Hey guys, what I'd like to do today is talk about the Nvidia RTX 3090 graphics card and talk about its overheating problem. Now, I'll be talking about the 3090, but this is a problem that does affect RTX 3080 cards as well. Both the 3080 and the 3090 have GDDR6X memory, and those chips get really hot, and Nvidia, I guess you could say it's a flawed design, but they're simply not cooling those chips well enough, and the temperatures of the VRAM are going up, and then the throttle and your performance goes down. Now, what I'll do first is just kind of explain the issue, explain what's going on, and then I'll talk about what I've been trying to do to reduce temperatures and try and resolve potential issues with temperatures and overheating and whatnot. So initially, if I go back a little bit, initially I was looking to pick up one Nvidia RTX 3080 or possibly two for my second PC. But as you know, there is a graphics card shortage, but I was fortunate enough to pick up the Gigabyte Aorus Master, if I can say it right, Gigabyte Aorus Master RTX 3090, and this performs well. But a few weeks later, I was fortunate again to pick up a 3090 FE. So that's the Founders Edition card. This is a little bit different, whereas that card has three fans spinning at the front. This one has one big fan at the side at the front and then another fan at the back. It also blows out air at the back, which is different from a kind of all air cooling solution there. But both of these cards do have the same problem. So as far as that problem goes, this is an article from Tech Power Up. It's a review of the MSI GeForce RTX 3090 Supreme X. Now, you can see at the top here, they've got pictures of the circuit board, etc. PCB stands for printed circuit board, and this, I guess you could say, is the front of the graphics card. There's the GPU, there's video memory. I don't know what every single thing here is, I'm not going to lie to you. I have watched videos from guys like Gamers Nexus and Buildzoid. All these guys are fantastic. But what you do need to know here is that obviously thermal paste will be applied on that, and then the cooler will be applied on that, the actual component to cool it. And that's the thing. That circuit board isn't big. It's not big. You know, it's quite thin. But these cards are huge because there's so much, going on here. There's a huge heatsink. There's three fans, and all of those fans are designed to cool all of those chips. And you can see what I'm talking about there. Three fans, big heatsink, all placed on top of that printed circuit board. And obviously there's a chassis around it to keep everything together. Now, that's the front of the graphics card. And as far as the core temperatures go, it's actually pretty good. So if I move this around, I can show you this. So these are some of the temperatures. You can see I've got Task Manager as well. So there's a few ways to check your temperature of your graphics card. And you can go into your Task Manager in Windows, you go down to GPU, and it will say 45 degrees. And that matches what I've got in MSI Afterburner there. Now, that will refer to your GPU chip itself. And I haven't had any problems with the core temperature. I really haven't had any problems at all as far as the overheating. It stays relatively cool, especially when you apply an undervolt. Absolutely no problems. I mean, these graphics cards are designed to run up to like 90 degrees or something as far as the GPU temperature. No issues like that. I don't even get close to that. Obviously, it goes up when I'm doing video rendering, when I'm playing games. Those temperatures will go up. The fans will start spinning to keep it cool. But I've been happy with it. Absolutely no issues with that. The issue, if I bring over this browser, the issue is on the other side of the card. So there is video memory. The 3090 has video memory at the front of the PCB, but there's also video memory at the back. Now at the back, you've got a back plate, and there's obviously like thermal pads between everything, but it's just not designed well. There's not enough, there's too much power, too much heat, too many watts, and it's not being dissipated through the back plate. So what happens is this back plate gets hotter and hotter, the heat isn't getting dissipated, and then performance will start to get throttled. So what's going on here is the video memory is being overheated and performance goes down. Now, this doesn't happen all the time. This will happen if you use up most of your video memory. And there's not too many applications that do that. There's certain games that could cause that if you put everything on ultra. Certainly when I've moved up to the higher settings, I have noticed the video RAM usage going up and up and up. There's certain video rendering situations, if you're converting files and different things, that will use a lot of video memory. And of course, there's cryptocurrency as well. If you're doing cryptocurrency mining, and I know cryptocurrency mining isn't popular, but if you spend like $2,000 on a graphics card, you're kind of crazy not to let it do some mining in the background when you're not using it to pay off the high cost. It kind of half justifies paying that extra. But when you're doing anything like that, where it's using a lot of VRAM, using a lot of video memory, it can overheat. Now, before recently, we were kind of blind as to what was going on. We really didn't know what was going on. But more recently, if I can get this here, more recently we've got a better idea what's going on because of this application here. So this is MSI Afterburner. Down here, I've got GPU Z. This has got a lot of really, kind of useful specs for your graphics card. This is part of, you can see I've just got it detached there or attached. This is part of MSI Afterburner, but you can detach it. It's just showing you the GPU temperature and different things. But HW Info, which is free to download, you can see it up here. This will show you the GPU temperature, 45 degrees, just like Task Manager and MSI Afterburner. But it also shows you this, GPU memory junction temperature. And you see down here, this monitor, that's it. That's the sensor. And you can see it's sitting about 50 degrees right now because I've only got OBS open. I'm not really doing anything. But if I open games, if I'm doing video rendering, or if I did have to do some cryptocurrency mining, that would shoot up. And it would shoot up very, very quickly. And all this relates to the video memory chips. That's the temperatures of those VRAM chips. And it gets hot. It gets really, really hot. So 50 degrees isn't a lot, but I'll tell you, that shoots up extremely quickly. And ideally, you want to keep that temperature, say, below 100 degrees Celsius, centigrade. But it's difficult to do that, depending on the situation. And what will happen is you can go up to about 110 degrees and your graphics card will operate normally. I mean, it will be hot to the touch, to the point that you could boil an egg on the back of your graphics card, but it will still operate. But once you hit that 110 degrees mark, anything above that can be extremely detrimental to the card and to the performance of the card. Now, I've read online that, over 120 degrees, you can really damage the card, but it does throttle it for you. And the overheating and the throttling can be quite bad. In fact, it can be bad to the point that the performance of your 3090, if it isn't cooled down enough, can actually reduce to even less than a 3080. I mean, I saw performance drop considerably. Once those temperatures get to like 110 degrees, which is what it's sat at all the time, it just starts dropping down. Now, right now, I've got my graphics card in the Thermaltake P3. It's an open case, doesn't have any cooling. And that's really good in a number of different ways, but it's not good for the graphics card. The graphics card really should be in a case that gets a lot of air, and it's not getting it in that case. So that's one of the issues that I'm facing. I have bought another case, and I will be moving all of those components into the new case soon. I'm going to have like 10 fans spinning in there, and I'm hoping to drop the temperatures. But let's look at some other things that you can do. Let's look at some other things. Now, I will say before I go on, if you want to learn more about the wattage and different things that's going on in the background, check out this video. It gives you a lot of information about what's going on as far as the watts that are being, kind of generated at the back of the graphics card. It really does kind of break it down what's going on. So you have a 3090, your VRAM temperature, as you can see from HW Info, your VRAM temperature is at 110 degrees or 105 degrees. You want to bring the temperatures down. What can you do? Well, there is a few things that you can do. There is a few things that you can do here. But obviously, you want to get an idea of your temperatures, install these applications, and get an idea of what's going on. And you want to do a lot of testing. That's what I've been doing the last few weeks. I've been testing lots of applications, lots of situations. I've been looking at temperatures, and then I've been changing MSI Afterburner settings. Now, I've used MSI Afterburner a lot. I've got a lot of experience with it, but just bear in mind that when you mess around with this, you need to be prepared that if you set settings too high or too low, you might face the blue screen of death, and you come back in, you're going to have to change things. So really what you have to do is be very, strict with how you're doing it all, very vigilant. Get a spreadsheet or something, write down the temperatures, write down the overclock, you've got for the power limit and the memory clock and the core clock. Just write down everything you do and then write, is it performing okay? Temperature's going down, performance going up. Detail everything. It will save you a lot of time in the long run if you do that. But as far as just dropping the temperatures down, what can you do? Well, you can just drop down the core clock here, but the best thing to do is do an undervolt. Now, you can be very specific with your undervolt and you can, bring everything down and put your graph up and down a lot. But one of the easiest things to do is just click on the first bit here, like this, hold the shift key, and then just pull it down like that. And then that will bring it down. Now, that won't actually be applied until you click this tick button. But if I have to click, it should be okay. You can see the line it's operating now. But if I had to click the tick there, that will apply it. Now, I just want to show you something. If you look at the power draw, where are we here? What I'm trying to find here is the power draw. Where's the watts? Okay, so you can see the board is hardly being used here. And we're at 48 watts, right? Now, full on, this can be like 300, 330, 350 watts. When you apply this, when you apply an undervolt, you should see that dropping down. Now, probably won't happen just now because nothing's actually been affected. But what would happen in a situation where you're using like 350 watts is you apply an undervolt of a few hundred millivolts, you'll probably see temperatures drop quite a lot because you should be getting the same performance with less electricity. Less electricity is less heat. Now, go through all that, read more about undervolting to try and see if you can drop temperatures. But just bear in mind, if there's anything that you're unsure of, if you're not happy with what you've done, just click the refresh button here. It brings you back to normal. But you can do lots of different things here. I mean, you can do kind of like hold this. If I click here, in fact, what was it, 825, I think I started it. See, I'll try and get to 825. It's quite fidgety to get into these. There we go. So 825, what I can do is do it like that, and then click tick, and then it does like that. You can go up and down like that, but you have to mess around with that. You need to learn a lot about that kind of thing. But really, what I'm trying to say to you all is you can do lots of little fixes here to try and reduce the temperature. One, put your graphics card in a good air-cooled case and get a lot of air at that graphics card. Get it at the back of the graphics card. Make sure that inside of your PC case is cold and you've got good airflow. All of that really does matter to the graphics card, especially at the back of the graphics card where there's no coolers. But the next thing you want to do is mess around with that undervolt. That has been, for me, the biggest thing that's helped me address this issue. I was getting like 110 degrees. It was throttling and performance was going down. I applied an undervolt, and yes, I was still sitting at 108 degrees, but the performance wasn't being throttled anymore. So my guess is before it was actually higher than 110, perhaps. I don't know. But by applying that undervolt, I can, drop temperatures, drop electricity use, but also the most important thing, that nothing was being throttled. I was still getting good performance. I wasn't seeing performance drop by a huge margin. So that's one thing. But there's a lot of other things that you can do. And I delved deep in this, and I looked into this a lot over the last few weeks. And I don't want to bore you with it too much, but there's lots and lots of suggestions out there. So one of the most common ones that you'll see is to apply aluminium or copper heat sinks to your graphics card. So this guy's got a good suggestion here. And you'll see lots of different suggestions as to what to do. You can see the heat sinks are on the back of the graphics card, and you'll drop the temperatures a little bit. And then he has put another fan on it. So I explored all of these issues. The first thing that I did, the very first thing that I did was, I've got one here, I've got one left, is bought some thermal pads. Now, I wanted to test every single thing on its own just to see what happens. So I bought about 10 of these. I put them all in the back of the graphics card, and I just applied them all, and I didn't put anything else there. I just wanted to see what happened because I saw a few people on Reddit saying, put some thermal pads on the back, it's enough to drop the temperatures a little bit. So I did that. I was monitoring the temperatures with the thermal pads on, and I didn't see the VRAM temperature change at all. Nothing happened. So the thermal pads alone didn't do anything, didn't really do anything at all. So that was my first test, my first, I'll give it a shot type of thing. I just wanted to see, this is the thing, I was speaking with my friend Mark about this, and he was kind of skeptical about a lot of it. Rightly so, I guess. But I was looking at a lot of people on Reddit, and they were saying, I applied thermal pads, I reduced it by 2 degrees. I tried this, I dropped it. And I wanted to experiment with a lot of it. But the thermal pads didn't really do anything. So then I opted for this. Now, I will say, in hindsight, this was not the best purchase. Not for this job anyway. This is a 240mm fan, but really it's two 120mm fans in the one chassis. Now, my thinking for buying this was that, one, it's one whole unit. I could have put two 120 fans or one 140 fan on the back of the graphics card and hopefully apply enough static pressure to blow cold air on the back plate. Hopefully it would, dissipate heat. And that's what I could have done. But I liked the idea of having one big fan that was longer. It meant I could put it at different angles. I wouldn't have to, hold two things in place. I had one thing and I could hold it in place. Comes with a PCI Express bracket so that you can attach it to your motherboard, and then you can place it directly next to your motherboard, your graphics card. And you can see on the back of the case that it advertises this. So this is advertised as a GPU cooler. That's how they advertise it. But I didn't get really good performance from this at all. I probably saw 2 degrees drop at most, but not really. It kind of dropped down 2 degrees and then just went back up. And there's a few reasons for that. I wasn't caring about the RGB, just happened to be part of it. The reason I think this doesn't work too well is that this has got a fixed fan speed of 1000 RPM. And I really should have opted for Noctua static pressure fans, a good static pressure fans. It's going to pull a lot of volume, a lot of air, and really drive that air into the back of the graphics card. Try and cool the back plate, try and dissipate some heat somehow. And this fan doesn't really do that. It's marketed as a GPU cooler, but the fans just aren't powerful enough. So it was my fault. I didn't do enough research at the time. I was kind of fooled by the marketing here as this being a GPU cooler. This will cool your graphics card. It just doesn't work like that. Now, I'm not too bothered about this purchase. I couldn't even actually get the PCI bracket slot to fit correctly, so I held it in place in a number of different ways. I will use this again, but I will say I tried many different solutions with this, with the fans above, to the side, below. I wanted to test absolutely everything, and I put this in lots of different positions. But initially I thought, okay, it's dropping 2 degrees. Truth be told, it didn't really make any difference. Now, again, that goes back to the issue of this being an open case. If that was a closed case, I might have got better results from this. I might have, but I didn't. Now, as I was saying before, these thermal pads, one of the reasons that a lot of people say that the 3080 and the 3090 has bad cooling for the VRAM is because the thermal pads that they use inside the chassis, connecting the fans and the heatsink to the actual PCB, etc. A lot of people say that those aren't good, and you can drop it by a few degrees again by simply using your own thermal pads. These are cheap ones, but get good thermal pads and just replace them in your graphics card. Now, I was a little bit reluctant to do that first. Maybe that's something I can explore in the future, but I was reluctant to get a screwdriver out and start messing about with the graphics card and the internals and start replacing thermal pads. I wanted to exhaust all other options first. So I went back to the drawing board once these thermal pads didn't work and once these fans really didn't do anything. I went back to the drawing board and I started looking at these aluminium and copper heat sinks. Now, I was leaning towards copper heat sinks, and here's a tip, guys. I don't know if you've got any kind of bizarre computing project in the pipeline, but if you are looking to cool something, copper has got much better thermal conductivity than aluminium. And that's the route I was going. And you can get these really huge copper heat sinks that used to be in like Dell servers, as you can see here. And they're not that expensive, not really. Now, I was very close to just buying one of these because they're so much more conductive. It looked like it would do better than aluminium. But I was also conscious of the fact that copper is extremely heavy. It's so much heavier than aluminium. And it's not like these graphics cards are light. They're not light. And I've got this 3090 Master, the Aorus Master. I've got it plugged directly into the motherboard. It's not, using a vertical GPU stand or mount or anything like that. It's directly into the motherboard. It's already 2 kilograms. adding another kilograms of a copper heatsink was not something that was on my agenda. It's too much weight. I didn't want to risk it. And that's why I went for aluminium heat sinks instead. I got 2 cheap aluminium heat sinks. I think it was about £12 for both of them. They actually arrived all scratched and dirty, but they seem to be doing the job still. And I applied those thermal pads to the back of the heat sinks. And the size and design and kind of structure of these heat sinks they don't really fit into the graphics card shape and size. Ideally, maybe I should have went for smaller ones like Norbert the Great did. You can see that if you go for these smaller ones, and you see many of these on Amazon and eBay, they're very popular and they're sold as being for the Raspberry Pi and different things. And you can place these about and you can maybe try and line it up with the video memory chips because that's effectively what you're trying to do. But I didn't want to go for something small. I wanted to try something bigger soon. So they weren't really fitting in with the memory, the actual RAM on my computer. So I tried lots of different positions and I really did put these aluminium heat sinks in many different positions. Now, the results were actually quite positive. They're actually quite positive. I'm quite pleased with it. So these only arrived today and they seem to drop it down between 2 and 4 degrees. Doesn't sound like a lot, but that's dropping me from like 108 down to like 104. Around that, or 110 down to 106. Now after that, I put the Aero Cool fan, or is the Aero yes, it is Aero Cool Astro 24. I put the fan on top of the heatsink, and that's just pushing it down, some cold air into it as well, because I knew it was transferring heat. The top of the aluminium heat sinks were absolutely boiling, so heat was being transferred there. So by putting on those heat sinks and putting on these 1 fan, 2 fans, however you say it, by putting them on, I've seemed to have dropped it by a minimum of 4 degrees. Sometimes it's 6 degrees. It kind of goes up and down. But I seem to have dropped it by 4 to 6 degrees by using a combination of aluminium heat sinks and this fan. Now, again, if you are looking to do this yourself, what I encourage you to do is do lots of trial and error. Lots of different undervolt settings, lots of overclock settings, underclock settings. Test everything, note everything down. See what puts performance down, see what puts performance up, etc. as well. But as far as actually cooling it goes, I don't think there's any replacement for having a good, well-cooled GPU, a good, well-cooled PC case for your GPU. And I've noticed that now. I don't know if this is because this is an actual PC case, but this one seems to be running maybe about 6 to 8 degrees cooler than the other card. Now, I don't know if it's because of this card, but my guess is because it's in that PC case with cold air blowing into it rather than being in an open case. It's just the GPU just isn't being cooled at all there. So that's something I'm going to test in the future. That is something I will test in the future. But for now, I truly believe that one of the best things that you can do is just put your graphics card in a well-cooled airflow type of case. You get lots of air circling around your big expensive graphics card. Thermal pads can be used with heat sinks and you can use fans as well. There are other things you can do. You can replace those heat pads if you're willing to open up your graphics card, and if you're willing to as well, you can open everything up and you can set up some sort of water cooling setup as well. There's brackets coming out, not brackets, sorry, there's water cooling solutions coming out for the 3090 that will help you do that. The initial water cooling solutions that come out for the 3090, they had all the water cooling was at the front, but not the back. But I know, for example, EK are coming out with one that's got a back plate that allows you to cool the back as well. So that's something to explore later. But I do think that for most people, for most of you, what you want to do is get lots of small aluminium heat sinks, or large ones if you go down the same route as me. You want to put them on the back, and you then, if you can, get some cold air onto it, perhaps put some fans onto it. I mean, this is very similar to what this gentleman did here. He's got some small heat sinks, he's got a fan on top. And it's the only thing that's really made a major difference so far for me. Now, as I said, once that goes into its own PC case, my hope is that I'm going to drop about 6 to 8 degrees. But right now, putting those aluminium heat sinks on and then putting the fan on top drops it by about 4 degrees minimum, sometimes 6. like I said again, if I had to swap this colourful, incorrect for this situation anyway, if I had to replace this fan with some really good high static pressure fans, I think I could drop it a couple of extra degrees. I really do think that. And that's what I'm going to be testing in the future as well. I'm not over with this. I'm going to try some other solutions. I want to see if I can cool this more with a good fan from Noctua or someone like that. Something with a lot of static pressure, something that's going to draw a lot of airflow from the surrounding air and try and cool the back of it. Still a lot of experimenting to go. So if you came here for a lot of answers, I don't have all the answers, guys. I really don't. This is something I'm going to be on, kind of testing, moving on into the future. Like I said, good airflow in a case. Try that undervolt as well. I think an undervolt is probably it could even be before a good airflow case would be to try an undervolt. You'll drop several degrees by doing that, and you'll make sure you're not throttling. It really isn't ideal that we have this situation. It really isn't, that you spend thousands on a graphics card. I mean, these graphics cards really at like $1,500 to like $2,000 or more. They're very expensive, they're very powerful, but the design is flawed. There's no way getting around it that the design is flawed on the 3090 and on the 3080 as well. But the 3090 in particular really overheats once the VRAM is being pushed and the memory is being pushed up, etc. So hopefully I've given you some ideas here, guys. Try them out, see if they work for you. I know some of you do have 3090s. In the future, I'm going to be monitoring all of this again once I put everything into the new case. And I'm going to be trying different fans. Maybe I'll pick up some different heat sinks as well. I don't know. But the idea here is that I want to get the most performance from my card. I don't want things to throttle and then I get lower performance. But also, I want to keep these temperatures low because I'm planning on keeping these cards for like 3 or 4 years or longer. I want these cards to last. I don't want to burn them out by running them too hot. So I want to keep those temperatures as low as possible. That's another reason why I'm experimenting with all of this. So thanks for watching, guys. I'll leave a link to all of the references which I've made in this video. I'll include a few links to Gamers Nexus, etc. They've done some teardowns as well. Thanks for watching. If you get any questions, or if you want to suggest anything that I do to try and drop temperatures further, please do let me know. But until next time, take care.